Students, today we will discuss about refraction of light through a prism. Refraction of light through a prism. So, all of you are familiar with prism. At least we can see what is meant by a prism. So, here you can see a prism. No, all of you can see the prism. No. So, now we will discuss the refraction of light through a prism. So, the principal section of a prism, if you draw, it will be like this. So, the angle between the two refracting surfaces, this angle is known as angle of the prism. Okay. Angle of the prism is the angle between the two refracting surfaces, that is known as the angle of the prism. Okay. Now, we will discuss about refraction of light through a prism. So, what is meant by refraction? Refraction means it is the bending of light as it travels from one medium to another medium. No? So, here also we will discuss what happens when a light is reaching a prism. So, what happens if the light is traveling from rarer to denser medium? It will bend towards the normal, and if it travels from denser to rarer medium, it will bend away from the normal. So, here we are considering a beam of light, a ray of light. PQ is incident on one face of the prism, on one refracting surface of the prism. So, this is rarer medium and this is denser medium. So, when light is traveling from rarer to denser medium, what happens? It will bend towards the normal. So, if you are drawing normal at this point, so you can see that it will bend towards the. Again, when it reaches this surface, what happens? At the surface AC, it is traveling from denser to rarer medium. Since it travels from denser to rarer medium, it will bend away from the. So, if you draw normal at this point, you can see that it will bend away from the. So, we can say PQ is the incident ray, QR is the refracted ray through the prism, and RS is the emergent ray. So, in the case of glass lab, you might have observed that the emergent ray and the incident ray, they are parallel. No? Emergent ray is parallel to the incident ray, or in other words, we can say that angle of emergence is equal to angle of incidence. But here you can see that those two rays, no chance that they will be parallel. So, if you extend the incident ray, you can see that this emergent ray and extended incident ray makes an angle. Here you can see an angle is made, and this angle is known as angle of deviation. So, what is angle of deviation? The angle of deviation is the angle made by the extended incident ray and the emergent ray inside the prism. That angle is known as angle of deviation. So, from this we can conclude that emergent ray is not parallel to the incident ray. Or is it clear? So, here we can write PQ is the incident ray, PQ is the incident ray, then QR is the refracted ray through the prism, refracted ray through the prism, and RS is the emergent ray. Okay, and of deviation. And D is the angle of deviation. So you can measure the angle of deviation by doing an activity. You can keep a prism on a white sheet and you can fix the white sheet and you can keep the prism on the white sheet. Then you can draw the outline of the prism. You can draw a line in such a way that it makes some angle between 30 degree and 60 degree, and you can keep two pins on the line. Then you can view the image of those two pins through this face, and you can keep other two pins. Then you will get the marks of the pin, and if you remove those pins, you get the marks. So that you can draw the line and you can measure the angle of incidence and angle of emergence, and you can get a relation between angle of incidence, angle of emergence, and angle of the prism and angle of deviation. So this is angle of the prism. So if you do that activity, you can see that I plus E is equal to A plus B. Where I is the, what is I is the angle of incidence, I is the angle of incidence, E is the angle of emergence. There is E can be represented here, okay. E is angle of emergence, A is the angle of the prism, and D is angle of deviation. Okay, so when you do that activity, you can observe that I plus C is equal to A plus D, where I is angle of incidence, E is angle of emergence, A is angle of the prism. For if it is an equilateral prism, angle of the prism will be 60 degree, and D is angle of deviation. Okay, so if you do this activity, you can observe the relation A plus D will be equal to I plus C. Is it clear? So all of you understood what is meant by refraction of light through a prism and why there is deviation. In the case of a glass slab, there is no deviation because the two refracting surfaces are parallel to each other. In the case of glass slab, we can say that the two refracting surfaces PQ and RS, they are parallel to each other. That's why there is no angle of deviation, or in other words, we can say that emergent ray is parallel to incident ray. But in the case of prism, there is an angle of deviation between the emergent ray and the extended incident ray because the two refracting surfaces are not parallel. Okay, they are making some angle because of which there is angle of deviation. Is it clear? All of you understood what is meant by angle of deviation, what is meant by refraction of light through a prism? Why there is deviation? Is it clear now? Okay. And now we will discuss another topic. So all of you have seen rainbow, no? Very nice to see rainbow. And whether are you seeing rainbow every time? No, in some there are certain conditions. So that time only we are seeing rainbow. We are not seeing rainbow at all the time. Why it is so? That we will discuss now. Okay. So before that, we will discuss a topic known as dispersion. Dispersion of light. Dispersion of white light. Dispersion of white light through a prism. Dispersion of white light through a prism. So already you have seen a prism. So when white light is allowed to pass through a prism, we can see beautiful colors. 7 beautiful colors can be seen on the prism. Okay, so how? that we are going to discuss. Prism is there and white light is allowed to pass. So when white light is allowed to pass through a prism, what happens is that, so this is the actual path. So from there will be deviation. So if you are keeping a screen, so we are allowing white light to pass through the prism, and if we are keeping a screen, we can see 7 colors varying from violet to red. Violet, which are the colors? Gives you no? Violet, indigo, blue, green, yellow, orange and red. So you can see 7 colors. That single white light is split into 7 colors. And this phenomenon of splitting white light into 7 colors, when it is passing through a dispersive media like a prism, is known as dispersion. So this dispersion is not taking place in any medium. For example, when white light is passing through air, no dispersion taking place because that air is not a dispersive media. It cannot split the white light into component colors. But when the white light is passing through certain dispersive media like prism, that white light will be splitted into its component colors. And the splitting of white light into its component colors is known as dispersion. So we can define dispersion as this dispersion, the splitting of white light into its component colors. Splitting of white light into its component colors when it is passed. When it is means when white light is passed through certain dispersive media like this. Okay, so when the white light is passing through, it will not disperse very time into 7 colors. So when it is passing through a dispersive media like a prism, in that case it will be splitted into 7 colors, and that phenomenon is known as dispersion. Okay, and which will be deviated most? This is the actual angle from actual path of the ray. From this, which will be deviated most? We can say violet is deviated most and red is deviated least. So why this happens? So that time Isaac Newton done a famous experiment. He thought that time scientists thought that this prism is producing color. Okay. Prism is producing color. When light is passing through that, prism produces its own color. Because of that, these colors happens like that. They were believing. They were not aware of that. It is split into 7 colors. So Isaac Newton did an experiment. So what he did is that he took two prisms. One kept like this, and another prism he kept up and down. Okay, and and he allowed the light to pass. White light is allowed. So when white light is passing through this, what happens? It will be split into 7 colors. So here we are showing only those the first and last colors only we are showing. Violet here and red. In between violet and red, remaining all colors will be there. Again, the same light is allowed to pass through the second prism. So here what they should notice, he could notice is that when a single prism was there, that it is getting splitted, but when he kept a prism inverted, he could see that instead of 7 colors, he could see white light, which means he concluded that it is not the peculiarity of the prism which produces the color. Actually, the single light, that the composite light, white light, is getting splitted into 7 colors. And here in this case, what happened? The first prism disperses the white light and the second prism recombines the white light into actual white light. 7 colors is recombined to form the white light. This is what happens. Okay. So, from this we can conclude that what is dispersion? It is not a contribution of the prism. Actually, the single composite white light is getting splitted into 7 colors. So, we can say it as there are 2 types of light. One is monochromatic light and another one is polychromatic. Monochromatic. So monochromatic light means single color. Single color light, or we can say that monochromatic light, single color light, or we can say that single wavelength light. Only one wavelength light. Okay. And in the case of polychromatic, many colors, many wavelengths. For example of monochromatic light is sodium vapor lamp. And for example of polychromatic, mercury. So this dispersion taking place only for polychromatic light, which consists of many colors. So those light, when composite light is allowed to pass through a prism, it will get split into its component colors, and that phenomenon is known as dispersion. And the spectrum, that color bands of colors that we obtain, we will call it as spectrum. Okay. Spectrum is the band of colors that obtains. For example, here Vibgeo, violet, indigo, blue, green, yellow, orange, red, those 7 colors we will say that we can call it as spectrum. Okay. And now we will discuss why dispersion happens. What is the cause of dispersion? So here already you have seen that the deviation produced by violet light is more and red light is least. Or we can say that in the case of air, all color of light will travel with the same speed. Okay. There is no variation in speed of light when it is passing through air or air. But when it is passing through a dispersive media like a prism, different colors of light will travel with different speeds. And violet has least wavelength. Violet has least speed. And red has maximum speed. So violet travels with least speed through the prism and red travel with maximum speed. And refractive index we know n is equal to c by be more and in comparison with red light, and the deviation, and hence the deviation produced by violet light will be more in comparison with red light. Okay, deviation is more for violet light and less for red light because of the refractive index corresponding to violet light is more in comparison with red light. Okay, is it clear? So this is all about dispersion. And now we will discuss about the beautiful spectrum that we can see, the natural phenomena that we can see in the atmosphere. It is rainbow. So rainbow formation. All of you have seen rainbow, no doubt at all. So when you are seeing rainbows, in which condition you can see a rainbow? For a rainbow to be seen, both days are needed. Both days are needed means it should be a sunny day, sun is must, and it should be a rainy day. If both these conditions are satisfied together, if it taking place, then only we can see a rainbow. That is, rain should be there, rain shower should be there, simultaneously sunlight should be there, sun should be there, then only we can see a rainbow. So both sunny day and rainy day taking place simultaneously, then only we can see a rainbow. And if a person is standing behind, if a person is standing in such a way that he is facing, sun is behind him, then only he can see a rainbow. So this rainbow is nothing but the dispersion of droplets present in the atmosphere. Okay, so rainbow formation, that three processes are there. One is dispersion, then internal reflection, and refraction. For the rainbow to form, these three processes are needed. One is dispersion, internal reflection, and refraction. And this dispersion, these tiny droplets is acting in the atmosphere, it is acting as a prism and it produces dispersion. So, if we are considering a 100 droplet, sunlight is reaching. So, this sunlight will split into components. Red will be deviated least and violet will be deviated most. And here, so this is the case of, so here you can see that at this surface, when sunlight is reaching at this surface, here dispersion is taking place. And here, when it reaches this surface, internal reflection is taking place, so the light will be reflected. And when it reaches here, again refraction is taking place. So these three phenomena contribute for the rainbow formation. This type of rainbow we will call it as primary rainbow, that brighter rainbow which is seen inside. It is known as primary rainbow. And one more rainbow you can see, that is a fainter rainbow, that we will call it as secondary rainbow. The one more internal reflection will be there, because of which the colors will be reversed. Okay, colors will be reversed. Is it clear? So here only one internal reflection is there. So we will see violet and red here like that. But in the case of secondary rainbow, there one more internal reflection is there, because of which the color of light will be reversed and it will be fainter in comparison with primary rainbow. Is it clear? Okay. So today what we discussed about the refraction of light through a prism and the dispersion of light and formation of rainbow. Thank you.